what we're going to look at is exponential growth. And all that means is we're going to graph an exponent, which right down here is our equation. And we're just going to plot those points. And we're going to see how the line going from left to right, and you can look right here, the line going from left to right goes up, and that's growth. So we're just going to prove that by graphing our points. So to do our equation, y equals 3 to the x power, we're just going to put in any x values that we want to do. And if you look over here, we have a -3, a -2, a -1/2, 0, 1, and they have 3 halves and 2. If you put these into your calculator and do the math, you end up with the points for y, which are, I'm going to highlight them, right there, right here, right here, right here, there, there. Now, if we plot those points, so if we look at what we have -3 and 1/27, which is a really small number, decimal. And then we have a -2 and 1/9, which is not as small of a number. I'm not going to do the exponent one, so I'm just going to not do this one. But if we do 0, we have 1. That one's a pretty easy number to graph. And then we have a 1, and it's the 3. That's our y value. I'm not going to do this radical, but if I go 2, and we get 9. So if we plot these points, and if you look over here, -3, 1/27, -3 is really close to the line. -2 and 1/9 is also close, but it's starting to go up. And then I go to 0, 1 right here, and then 1, 3, and then finally 2, 9. And if we were to do our next number, you probably predict that it would be way up. And so the graph, if you connect those dots, is a graph that goes up. That's why it's called growth. And so it's just a matter of putting in any number you want, starting with some negatives, and work your way up to positives and see what kind of graph you get. Just like for growth, we have decay, and decay means things are going down, decaying, going down. So if you look at our graph here, it's going down left to right. So let's go ahead and prove that by looking at our points. Once again, you can put any values for x that you want, and here they are, -3, -2, -1/2, 0, 1, 3 halves, and 2. And it doesn't matter which ones you pick as long as you have some negatives. Right here, 0, you always want to pick 0, and some positives. And so our points are -3 and 27, -2 and 9. And I'm not going to do the radicals just like I did on the last one, but we have 0 and 1, 1 and 1/3, and then I'm not going to do the radical, but I'm going to do 2 and 1/9. So if you look at these points, -3, and you go up -3, it's going to be way up here. -2 and 9, which they have on their graph, 0, 1, and then 1 and 1/3, which is close to the graph because it's a small fraction. And same with 2 and 1/9. And if you kept going, it would get closer and closer. So you can see going left to right, the graph goes down if you connect those dots. That's called decay. So all it is graphing points by putting in whatever numbers you want for x values and picking some negatives, some positives, and zeros and see what you get.